People have been fascinated by the cosmos since ancient times. The idea of infinite expanse full of different phenomena that we can't explain has really made it an extremely interesting topic. Lots of science fiction authors, as well as scientists, have really drawn inspiration from the cosmos to this day. In my opinion, one of the most interesting phenomena that we still try to understand is the black hole. With its mind-blowing power and mysterious nature, it's one of the most famous and captivating wonders of the cosmos. At this point of our development as a race, our knowledge of black holes cannot go beyond the edge. This threshold is called the event horizon. Its name comes from the fact that absolutely nothing, even electromagnetic radiation, cannot escape the black hole. That means that whatever we send, a spaceship or an astronaut, will be destroyed by the devastating power of black hole's gravity. Imagine you're an astronaut and you're traveling to the black hole. Eventually, you're going to turn into a tiny string of atoms waiting for their doom. I really like the example of the feeling if you're falling towards a black hole. Imagine you're a swimmer swimming with the flow of a river. But you don't know that ahead of you there is a waterfall waiting. The moment that you start following, it's going to be too late for you to go back. That means that if you're going towards a black hole, your speed is going to be constantly increasing until you reach the event horizon. At that point, there is no returning back. In my opinion, we should not treat black holes as a threat. Although they are a very powerful phenomena, I think if we understand their nature, we will achieve a milestone in human knowledge. And if somehow we manage to go beyond the edge of a black hole, I think it will greatly change the way that we perceive the universe. Even if we can't directly use the black hole as a type of a resource, the knowledge that we will gain, I think, is going to be priceless. As you know, one of the world's most famous physicists is called Stephen Hawking, and I really appreciate the time and dedication that he spent researching the black holes. One of his most famous theories are about Hawking radiation, and it has been proven to be true. What I don't agree with him is about the baby universe theories. That is, that if a black hole is emitting Hawking's radiation, it's going to create a whole different universe with a space-time only for that universe. I don't think that black holes could be so powerful that they can change and create a space-time for themselves that later on can interact with our space-time. I don't agree with this theory because I think that black holes can have a different purpose in the cosmos. As you know, 85% of the matter that is in the cosmos is called dark matter. Its name comes from the fact that we can't observe it or either interact with it. The other 15% is usual normal matter that we usually use in our daily basis. I think that black holes could be the reason that dark matter exists, and it converts regular matter in some type of way that we cannot no longer observe. In fact, the incredible power of black holes can actually be used to our benefits. We use two methods of creating energy from the mass of an object. One is chemical reactions and the other one is nuclear fission. Chemical reactions are so ineffective that we really don't think of them as converting energy from the mass of an object. In fact, only 0.00000001% of the actual mass of an object is being converted. Nuclear fission, on the other hand, can get up to 0.1 to 0.7%, which is still quite mediocre on an absolute scale. On the other hand, black holes, if stationary, can get up to 6% efficiency, which is way better than what we're using right now. And rotating black holes can get up to 42% efficiency, which is almost half of the mass of an object, which is an insane amount of efficiency. The way that we're going to use black holes to convert mass into energy is if you throw something in a black hole, it's going to gain a lot of kinetic energy because of the great gravitational pull. Then, if the object collides with something, it's going to heat up. Then this heat is going to radiate away in the form of infrared radiation. Then we're going to be able to collect this radiation and collect the energy. In conclusion, I would like to say that the edge of a black hole is in some way the edge of human knowledge in physics, and if we somehow manage to go beyond that threshold, I think new opportunities are going to be awaiting for us, a new way to develop our civilization.